here, we can see that there's a hole in there, and that hole's absolutely concentric with the outside of the shaft. And so what we're going to do now is we're going to put the max system on it, and we're going to double check our work, because as the angle has changed, we haven't really pivoted the frame. And what I mean by that is this is our steering head, and we go right to the center of this, and we rotate this around this way. Then we know that our trig is absolutely perfect. But in the real world of a motorcycle frame, if you remember, this is all attached to this. This goes down to swing arm pivot here. And what can also happen is that this is held at the top and held here, so this would actually stretch this dimension out rather than pivot this around the center. So what we need to do right now is we need to actually check to make sure that this distance just hasn't changed and that we've actually put enough of an angle in it. So we're going to do that right now. Okay, so we're set up and ready to measure again. So what we've done is we've loosened the bolts at the bottom so that we could slide the bike back and forth. And then we've got our mounting post here this time, which is a V block. There's a V in here. And we've got that held tight against there with no slop on this machine surface, which goes through the center of the shaft. So we are in fact measuring the center of the shaft actually more accurately now than when the whole bike's assembled, because this is kind of a zero fit where the steering head actually has some slop in it so that the steering head bearings can turn. So we're going to go ahead and measure this now. Okay, so that's nice and in the center. And then where it says turn to the left, turn to the left. Okay, so then we're turning the bars to the right, which would be moving the target bracket to the right. Then we're going to go ahead and measure again. Okay, we're going to turn back to the left again to verify the first measurement. And again, that doesn't have to be clocked in exactly the same position, but it just needs to prove to itself that nothing's moved. So now what it's asking for is it wants to know where the bottom of this casting is. And I guess this is a good time to actually show you that. It wants to know where the bottom of this casting is, and we're going to show it where that is by using this bottom part of this. Okay. We go to get results. Okay. All right, so this is what our goal was, and physically it would be impossible to change some of these dimensions, but when we look at this, we see that we're within, on our B dimension, which would be our vertical representation, we're within 1/10 of a millimeter. We're 7.3 millimeters longer than we really wanted to be to make it an actual 05 GSX-R 1000. But we see that our steering head angle is within 0.04 of a degree. So all in all, we couldn't be any happier about this. And we're very excited now, because what we're going to be able to do is maintain our steering head angle at 24, which is what we're going to need with 32 millimeters of clamp offset. And we're going to be able to have a much greater swing arm downslope, maybe 12.6, 12.7 degrees, which is not going to be what it is on the new GSX-R with the swing arm pivot where it is, which is up to 13.5 degrees. But boy, oh boy, is Sean's bike going to work a lot better on the gas for the second half of the corner. So we'll see you at the CMS. So now we're going to get all the new measurements. So we're going to go ahead and do a regular measurement now. As you can see, we have the front wheel off the ground, and we have the front and rear suspension completely topped out. It's the way we measure them. So now we're going to enter in everything into the computer and find out how much good we did. As you can read the message here, it says CMS completed, and it gives us our CMS angle, which means absolutely nothing to us. It does mean something to the Max machine. So as I've always said before, OK means to proceed, so we're ready to proceed. So then we would go to the results. Then we see the bike is here, and we would click onto CMS results. It would ask us to enter in additional data. For example, we would need to know the circumference of the front tire, and we know that's 1905 millimeters. We would hit our tab button. The next thing is circumference of the rear. It's 2020. The next thing that we need to know is the height of the front height, which we said was 126. Hit our tab button. Height of the rear is going to be 106. Hit our tab button. Now it's asking for rear height. And what they're asking this for is that if you had a spot from a spot on the swing arm right above the axle to a spot on the bodywork, you could put that number in there and actually have a reference number. So you know at 350 millimeters, this is what it is, so you could always double check yourself. I'm not a big believer in changing a bunch of stuff at the track. I kind of know what I know, and I'd like to make a change in a nice controlled environment. That's why that option doesn't mean much to me, but that's what that's for. The distance on the front is 883. Distance rear is going to be 543. Our offset of our clamp is 32 millimeters. So then we would go to the next thing. We're still very, very fat here at 24.4 and 102.3. We really want this to be about 24, and we want that to be right at 100. And what we're going to do then is go to the simulation page up at the top. And then now we're going to take our measurement here, and we're going to add 10 millimeters to it and ask it to calculate that. And there it is. So we actually need to lift the rear of the bike up 10 more millimeters, and then all of our numbers will fall in exactly as we wanted. We have a very nice swing arm angle of 12.7, which is nowhere near 13.5 of a new chassis, but we see that by lifting the back of the bike up, we still have our 24.0, 100 millimeters of trail even, and 12.7, which is very, very good. If you remember, this bike was at 24 or 23.8 and 97 or something, or 98 millimeters of trail, and had a swing arm downslope of like 12.3. So we've really done some good here. So we're going to go ahead and make those changes. So here it is after we've raised the back of the bike up 10 millimeters according to our simulation. And you can see that we wanted 24 degrees, and we got 23.9. The trail number we wanted was 100, it's 99.6, and we're actually at 12.8. So I'm wondering how much I missed it by, so I'm going to go to the simulation page. Since we're too tall in the back, obviously, right? So because we're not at 100 or 24 degrees, we're going to hit the minus button and see what 1 millimeter does. And if we recalculate that, hey, there it is. So it's just like it said it would be. It's 12.7, it's 99.9, and it's 24. If you remember the simulation page from before, we're within 1/10 of a millimeter on everything. So I guess right now I'm going to go ahead and lower the back of this bike 1 millimeter, and we're going to be ready for the track. So we're all done here.